Huff, my stomach is relieved after eating a lot of savory sweets and dry fruits in the Diwali celebration. But there's always a savior, which is maths, and I didn't forget about it. So I also hope you guys didn't forget about it. And if your stomach still pains after Diwali, then just check this video. You will also be amused, and also I think so your stomach pain may go because of your amusement. So let me tell you what I've got today. But before starting, do not forget to subscribe to my channel to whoever has not subscribed. Okay, let's begin. I've got an interesting topic, and the topic is called triangular numbers. We're gonna find it, like what do we gonna see how we're gonna find it. We're gonna know what are triangular numbers. We're gonna do few puzzles with it and many other things, like many other mysteries and stuffs about it. Okay, so let's begin. Triangular number. Okay, when we say triangular number, it name suggests that it's something related to a triangle or bio. That's why there's a triangle here, which is very weird, but that can be related here. Okay, let's see. So, when talking about triangular numbers, it's basically the number of circles which can fit inside a triangle or form a triangle. Like if I take three circles, that too arranged in any way. Okay, I've arranged it like a pyramid because that's the only way they form a triangle. They wouldn't fill up all the spaces, but then that is how you keep it, okay? Because it's a circle and it cannot fill all the spaces. Or you can also take triangles. Just take triangles and fit them inside a triangle like this. But what the problem here is that this would give you a wrong triangular number. That's why we're using circles here, okay? If I take another example, like I've drawn three circles down, I'm making the 3 to 1 pyramid. We would have seen that everywhere. But do not mind about my circles, okay? They may not look clean. Okay, leave that. Now, how are we gonna find it? It's pretty simple. So, what you gotta do is just, think about it. If you don't know or have no clue, then just assume this video. So, if you're gonna find the third triangular number, okay? Just put third. Your formula will be n into n plus 1 divided by 2. What does n represent here? Sometimes n represent in different formulas as 3, 1, 2, 4, but here it represents the number 3. Not always, okay? Because here you're finding the third one, your n represents 3. If you're finding the fourth, your n represents 4. Okay? So let me just, replace these n's with all the 3. So 3 into 3 plus 1 divided by 2, which is 12, divided by 2, which is equal to 6. Okay, there's another substitution. If you don't want to put 3 plus 1, you can just, put the next number after 3. What's after 3? 4. Just put 4. Okay, it will be more convenient for you, or you can just put n plus 1. Now let's take the fifth triangular number. Okay, so we're just gonna put 5 because the n is 5. We're gonna find the fifth one into the next number 6 divided by 2. So 30 divided by 2, which is equal to 15. Okay, this is what we get. There's one more thing with triangular numbers. You can find square numbers using them. I'll show you how. And this formula can be used for anyone. If you're finding the 12th, 100th triangular number, you can use this. Okay, now let's see. How will you find the square numbers using triangular numbers? Let me just write the first 5 triangular numbers. This 10 and 15. You all like addition, don't you? So just add these. First one, 4. And before that, put a 1 here because that's your first square number. 9 because 6 plus 3, 6 and 10, 16, 10 and 15, 25. This is all your square numbers. 5 into 5, 4 into 4, 3 into 3, 2 into 2, 1 into 1. Right? So, there's one more pattern in triangular numbers. The pattern in these numbers is that 1 plus 2 is equal to 3. 3 plus 3 is equal to 4. We take 6. 6 plus 4 is equal to 10. And 10 plus, that's a 5. Okay, it looks like a 6. Just put it as a 5. 10 plus 5 is equal to 15. 2, 3, 4, 5, 6, 7, 8, 9. But I don't think this would be more difficult for you to find triangular numbers if they're not in a sequence. Because if they give you this and then they ask you the 20th, you can't keep on doing plus 6, plus 7, plus 8 till you reach 20 numbers, right? So I don't think this will help you, but then this can help you when you're finding with like just 2 the next. And you don't want to do this problem, n into n plus 1, okay? So now let's do the puzzle with it. The puzzle is familiar with everybody, but I'm not sure who all know how to do it. Okay, let's see how it works. This is a puzzle. We might have seen it everywhere, mostly, like in our books and all the other Olympiad stuffs, right? But here's a simple way how to do it instead of counting. Or who likes to count, will sit there counting 1, 2, 4, 5, 6, 7, and so on. But that's not how you do it. You can do it that way, okay? But this is a easier way. So we're gonna use triangular numbers here because it's a triangle filled with triangles, and we have to find how many triangles are there. So let's see how to do it. First, we're gonna write 1, 2, 3, and 4. We're gonna write our first, second, third, fourth triangular numbers like 1, 3, 6, and 10. If you don't if you don't want to do this way, there's another method too. You can put 1, 2, 3, and 4. Okay, now you're gonna do with 1, you're just gonna put direct 1 because these two are equal. Then when you put a diagonal, it means plus. So you're gonna put 3. Diagonal means plus. You're gonna put a 6. Diagonal means plus. You're gonna put a 10. It's the same thing you got here and here. Okay, the next step is to add all of these. I get a 20, and here obviously a 20. But that's not it again. From here, this time you have to arrange it in this straight line manner, so that you find it easy. Okay, you cross this number, take this, cross this, take this, add all these tick numbers to this. 6 plus 1, 7, plus 7, which is equal to 27, and this is our answer. Okay, so it shows there are these many number of triangles in this instead of sitting and counting. Now let me show another variation, but it's not the same. This one. Okay, so let's see how to do it. We are not gonna do that. We're just gonna write 1, 2, and 3. In this type of puzzle, we're gonna take the last number 3 and find its triangular number, which is 3 into 3 plus 1, which is 3 into 4 divided by 2, which is equal to 6. And our answer for this puzzle is 6. Clear? So this is how we gotta do it. Now for this one, it is same, but it has one more extra. So we just put it 4. We find the fourth triangular number, which is equal to 10. It shows us there are 10 triangles in this. You may wonder, how can there be 10 triangles in this, right? But that's how many there are triangles in this. Okay, like just take 1, 2, 3, 4, 5, the whole one, 6, 7, 8, and let me see from where, all 9 and 10. These three, one, and these three, another one. Okay, that's it. I don't think there are more, okay? So that's how we do it. So these triangular numbers are also found mostly everywhere, but we have to just become a detective and spot them out. I'll show you one example, okay? This is called a Pascal's triangle. I don't think you guys would have heard about this or seen this, but then this is a Pascal's triangle. It was named after the famous French mathematician Blaise Pascal. That's why it's got its name, Pascal's triangle. So, it has a speciality which makes it different from the others. It is basically when you add the top two numbers, 1, you get the middle number, which is 2. When you add these two numbers, you get this. Okay? 3, 2 plus 1, 3, 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4, and many more. It continues. Okay? The second speciality is that it contains natural numbers 1 to infinite and also triangular numbers. Okay? It depends on the number of rows you're making. Here there are 3, 4, 5, 6, 7, 8. 8 rows. So there are 8 rows, so there'll only be 7 natural numbers. If you put 9 rows, there'll be 8 natural numbers, okay? Okay, there are two things about this Pascal's triangle. The first thing is that you can extend these rows as much as you want. You can put another one, and then extend it. But the only condition here is that you have to put a 1 and a 1 to make sure that you are, you know, extending the rows and you get the correct answer, because the 1 is must, because that will help you when you add. Next thing is that this rule or this way of this Pascal's triangle is being used in most more games and stuffs. Now games and few puzzles. I'll be showing one of the puzzle of the game based on Pascal's triangle in my video soon. So that's it. Now I'll just show you where are the natural numbers and the triangular numbers hiding in this Pascal triangle. The natural numbers are right here, okay? And the other one is here. So the other thing which I wanted to say is that when there's one thing on this side, there's always the same thing on the other side. Now for triangular numbers. These are the triangular numbers, right? Same. Here are the other pair. Okay, that's it in this Pascal's triangle. And these numbers are different numbers. Okay, they're just normal numbers. Next, I think so. Next, I'll be showing you another puzzle which is similar, which has triangle numbers, or you need triangular numbers to solve that puzzle. So let's see it.